For our last lesson, we have the lesson 12, which is the centroid and moment of inertia. Centroid is the moment of an area about an axis, centroid of geometrical figures such as squares, rectangles, triangles, circles, semicircles, and quarter circles. The moment of inertia is a quantity that determines the torque needed for a desired angular acceleration about a rotational axis to how determines the force needed for a desired acceleration. It depends on the body's mass distribution and the axis chosen, with larger moments requiring more torque to change the body's rate of rotation by a given amount. Here are the formula of moment of inertia. We have the rectangle. So for our rectangle, we have the base times height cube over 12. And for our triangle, we have the base times height cube over 36. And for circle, we have pi r square root of 4 or pi r4 over 4 or pi d4 over 64. And for semicircle, we have the 0.11 r4. And for quarter circle, we have 0.55 r4. And last is the ellipse. We have pi ab times ab cube over 4 and the pi ba cube over 4. So we have here a problem that says determine the centroid of the figure and the centroidal moment of inertia along x-axis. We have here a circle and a rectangle. As you can see, the measurement of our circle, the diameter of our circle is 50 mm, and the base of our rectangle is 20 mm, and its height is 10 mm, and the height of another rectangle is 30 mm. So since these are connected, the base of our rectangle is also 50 mm. So to solve our problem, we have to first find the area of rectangle, which is, the formula is base times height, and the area of circle, which is pi r squared. So for our moment of inertia, we're gonna use for rectangle, the Lx is equals to base times height cube over 12, and for our circle is pi r4 over 4. So this will be our area 1, area 2, and area 3. So for area 1, we have pi times 25, since the diameter is 50 and the half of the circle, the radius of the circle is half of the diameter, so it is 25. So it is 25 squared. So pi times 25 squared is 625 pi. And for our area 2, we have area 2. We have base times height, which is our base is 50, and our height is 40. So it is equals to 2,000. And for our area 3, we have our base, which is 20, and our height is 10. So it is equals to 200. And to find our centroid, for area 1, this is gonna be our y1. So this, and the question said is along the x-axis. So this is our x-axis. So to find our centroid is the half of the circle or the radius of a circle along x-axis radius along x-axis, since this is 25 plus 10 and 30 is equals to 65. For our centroid number 2, we have the rectangle, the big rectangle. So half of the rectangle, since this is our x-axis, and half of rectangle, since the height of rectangle is 30, so half of rectangle is 15 to x-axis. So our centroid number 2 is 15. So for our centroid number 3, which is the small rectangle, since this is our x-axis, we have the 10. Half of 10 is 5. So the half of 10 is 5. Along to the x-axis is 5 plus 30 is 35. So next is we're gonna compute the moment of inertia. So our inertia 1 is a circle. So since the formula of the inertia of circle is pi times r4 over 4, so it is pi times 25 square 4 over 4 is equals to 490.874 millimeters squared. So for our inertia 2, we have the formula of moment of inertia of rectangle is base times height cube over 12 is we have our base, which is this is our inertia 2. We have our base, which is 50 times height is 40. 10 plus 30 is 40 cube over 12 is 266,666.667 millimeter 2. So for our inertia 3, we have the small rectangle. So same formula, base times height cube over 12. So it is the base is 20 times height 10 cube over 12 is equals to 1,666.667 millimeter. So for our area total, we have to total our area to get our centroid. So our distance. So we total the areas, the area 1, area 2, and area 3, which is 625 pi. This is only pi plus 2,000 and plus 200. So the total is 4,163.495. So to compute for our centroid, it is area total times centroid is equals to area 1 times centroid 1 plus area 2 times centroid 2 and plus area 3 times centroid 3 or y3. So direct sub area total. Our area total is 4,163.495 times centroid is equals to area 1, 625 times y1, 65 plus 2,000, our area 2, times 15, our y2 plus 200, our area 3, and times 35. So, this is 15. So, for our centroid is equals to 39.540. Now, we're gonna compute the inertia total, or the total inertia. The inertia total formula is equals to inertia 1 plus area 1 times centroid minus y squared. So, and so on. So, direct sub. So, to compute our inertia, we have the 490.874, our inertia 1 plus 625 pi, our area 1 times our centroid 39.540 minus our y1, which is 65 squared, plus our inertia 2, which is the 266,666.667 millimeter 2, plus 2,000, our area 2, times our y, or our centroid 39.540 minus 15, our y2 squared, plus last is our inertia 3, which is 1,666.667 millimeter 2, plus 200, our area 3, times 39.540 minus 35, our y3 squared. So, the total is our total inertia is 2,309,330.228 millimeter raised to 4.